All right. Hello, Professor. Um, so I will say, unfortunately, I have lost VR privileges, um, and uh, I didn't I didn't have enough time in order to do latex for both of these problems. So we're gonna do it this way, and hopefully I can revisit it back in VR. I feel like this would definitely be a fun one, especially if we could draw the graph. But so for our first problem here, we're going to do 5.6.5. The question is, we're asked to evaluate the integral of x tan x, and see why we can't use a u substitution or integration by parts. So what we have here is the integral, definite integral from 0 to 1 of x tan of x tan x d of x. And so if we try it using u as x and dv as tan of x d of x, we get v equals secant squared x and du equals dx. And then we get this really nasty integral down here. That's not an eyeball integral. So, it ain't that pretty. And then if we try it using the other way, so just backwards pretty much, where u equals tan of x, dv equals x, so du would be secant squared x, and v equals dx. And we plug that in, we also get this pretty ugly integral. So it'd probably be best if we didn't do that to solve that, right? That's where we get into midpoints and left intervals, right intervals, and midpoints of the graph. And so we're gonna do Riemann sums, and then down here we get to do Simpson's rule, which is also really fun. So for our left intervals of the graph from 0 to 1, we're gonna have 0, 1/4, 1/2, and 3/4. And since we're going by a fourth, we're going to have to divide by 1/4 here. So that's what we'll be using during this entire, I guess, problem set. So we kind of just plug and chug. So 0 tan of 0 plus 1/4 tan of 1/4 plus 1/2 tan of 1/2 plus 3/4 tan of 3/4 give us 0.25892. And then we'll do the same, of course, for the right intervals and the midpoint intervals. Midpoint, we'll get our interval values from 1 to 8, 3 to 8, 5 to 8, or no, 1/8, 3/8, 5/8, and 7/8. And so we plug that, we get 0.64827 for the right interval, 0.41550 for the midpoints. And then in order to find T4, it's just the average from the left and right intervals. And so we plug those numbers in and we get 0.45360. Now Simpson's rule is pretty cool. So if we multiply the midpoint intervals by 2 and then add it to T4, and then, or the average of the left and right, divide that by 3, we get 0.42820. And if you actually go in and solve this integral, definite integral of 0 to 1 of x tan x dx, you actually get this. And that's the cool thing about Simpson's rule. So it gives you the exact number value down there. And then the last part is just asking what are underestimates and what are overestimates. So L4 and M4 are underestimates, and R4 and T4 are the overestimates. As a reflection, really sorry that I wasn't able to do VR. I should have planned ahead just in case something like this was to happen again. Really sorry about that. And I feel like I jumped around. I didn't really stay like going down. I felt like I jumped around back and forth and up and down. So that's something I gotta get better on. But you'll probably be seeing some more, or be seeing some latex since I can no longer do VR. So hopefully those will be as entertaining as these videos. But yeah, this is part 1 of 2, and part 2 of 2 is coming out soon. Have a great day.